Deeksha. And I am sure she will have a really nice and interesting talk for you all that's related not only to React, but in general, from an architecture. So for the ones that just joined in and tuned in, I want to say welcome. And for the ones that have been with us for quite some time, I want to say welcome back. So without further ado, I will pass it on to Deeksha. And yeah, the screen is yours. Let me just share your screen. And yeah, you're up.
All right. I can start?
Yeah, please do.
Okay. Hello, everyone. My name is Deeksha Sharma. I work with the product development and engineering team at Crystallize, and that's like a short and crisp introduction. My topic today is headless architecture and how to avoid front-end monolith. But before we see how to avoid front-end monolith, let's first understand what a monolith architecture is. In a monolith architecture, everything looks like this large block in this unified piece. Something is monolithic, it also means it's too large and not very easy to change. From the standpoint of software development, or to say web development, because it's React conference, no web application or site is complete without integrating with the third-party services and some backend APIs. We also have a front end, which we want our customers to interact with. And then finally, we need to deploy it, package it somewhere, either in the cloud or have companies have their own data centers. In the monolithic architecture, the problem is everything is very closely connected, and it resides in this one single piece of code. And this is what our code base looks like in a monolithic architecture. Monolithic is not always bad. If someone is starting out, if they have a very small application, if they don't want to worry about splitting their app into different pieces, it can work out. However, when someone wants to scale and you want to have a team that works on it, it becomes painful. Let's see what are some of the things that makes it painful. This tight coupling leads to error-prone releases. And whenever you are thinking of doing very simple things such as a UX refresh, you have to ship this gigantic code base, which, because of its tight coupling, is more error-prone. It's not that you would never ship issues, you would never have regression, but the probability of errors increases when we are touching multiple pieces in a single large code base. There are other problems such as code duplication. If somebody wants to distribute their code to different channels, so let's say I have a web application that I want to distribute to my customers as a web application, as a mobile app, or maybe as a browser extension, I want to give them some features or functionality to use. And this is like a multi-channel experience that I want to give for my piece of software. In a monolithic architecture, if you are shipping, you ship a code that looks like this, where you have a lot of code duplication and your teams are going to have a hard time identifying any issues with the backend that needs to be fixed in another code base. So when you have multiple copies of code base, it's a nightmare. And we are not reusing the code bases from the backend or from some of the development scripts that we can reuse. We are not doing anything. We are simply shipping these large pieces. Now that the other aspect of monolithic architecture that is equally painful is that often we end up using outdated frameworks and legacy systems if we are integrating it with third-party vendors, which is not developer friendly. None of the developers today want to work on legacy technologies. And if we have to hire somebody who is adept at working in legacy systems, it would be equally hard. They are very much logged in. These kind of systems, the monolithic systems, are often logged in by using specific programming language or how the data should be stored, which database, how they should be deployed. And since we are working with such an outdated framework and legacy system, they are not easily integrated with the modern technologies and the modern programming languages. If we are using the UI, we are very much limited to some of the UI templates and theming that comes as part of that legacy system. And there is very little room for customization if we want to provide our users with a seamless and nice user experience that is customized as per our own brand needs. And finally, the deployments are hard and time consuming, because if we are not using some of the modern deployment and hosting services, we are very much dependent on small teams that are working on very specific deployments, and we have to wait for much longer in order to ship even a single feature or a bug fix. Now, what is headless architecture and how does that help? If you look at this image, you might already notice that the headless architecture is, if you assume it like a human being, it is just changing heads and the torso remains the same. And these heads are nothing but different front ends. And the torso is nothing but the headless services that we use as part of a web application. What does it look like in a web development standpoint? Headless architecture has 3 layers. It has a front end. It has this middleware layer, which is also called as API gateway. At Crystallize, we call it Service API, consisting of some server-side APIs in GraphQL or REST. And then a collection of headless services. And this middleware talks to the headless services and then sends the response back to the front end. This middleware is nothing but sort of a fully managed service, and it makes it easy for the developers to create, publish, maintain, monitor APIs at any scale. So you can assume that this APIs in this service sort of act as a front door for applications or the website to access data, business logic, and functionality from the backend services. Now, when we separate the front end from the back end, it gives us speed. It gives us agility to change and adapt. And it also gives us the ability to customize the user experience for the end users. And we don't have to depend on some pre-existing UI templates. From the front end standpoint, it could be an app, it could be a website, or it could be an e-commerce store. What are some of the benefits that we get from headless architecture? We straight away get decoupled front end from the box. Now, let's say if I want to do a UX refresh, all I need to do here is I have to release the front end without having to worry about the middleware or the third-party services that I'm using, as long as the API contract between the middleware and the front end remains the same. If we plan to change something in the middleware, we will release the middleware separately. But we do not have to ship and release the entire one single large block of code base. The next advantage that we get with regards to the omni-channel experience is we are able to reuse quite a bit of code. So if at all I have an application that needs to be distributed across multiple channels, such as web, it could be a browser extension, we could even distribute our software to the kiosk or a mobile app. Now, having this kind of composable stack, it allows us to reuse the middleware code. The backend is separate. It has some APIs exposed. You have the third-party integrations and services that will be accessible by the middleware layer. And all you need is these different heads for each of the channels to just fit on top of this torso. Using headless architecture is pretty much like playing with Legos. You can remove parts that you need and that you don't need, and you can add the new ones that you need. And the possibilities are endless. And all of these channels are pretty much, as you can see, use the same middleware layer. Let's say I want to experiment or beta test the UX refresh on web, mobile, and kiosk front end, but I want to leave the browser plugin as is with existing features. We can do so by just touching the front end code for the 3 channels that we want to change and keep the browser extension as is, because we didn't change the middleware layer at all. The next thing is, and I would say this is one of the biggest advantages, which gives speed to the developers and to the companies to ship something out. We are able to leverage the modern technology stack. It is developer friendly. Every developer wants to use what is best and what is the latest, and they will be able to use there and translate their skills from one product to the other. We are also given a benefit when we are using headless architecture by making use of modern frameworks. Since I have only kept React frameworks, but it is agnostic of React. It could even be a plain JavaScript. It does not have to be React, but you can use any modern framework, fit into it, and ship it. Now that we are not using any legacy systems, we are not taking any UI templates from any third-party vendor, we also have possibility to customize the user experience as per our own needs. Because we maintain our own front end, we can have a beautiful design, we can have beta testing the way we want. And finally, when we combine this with the modern hosting services, we are able to leverage the capabilities of caching. We are also getting the capability of generating the preview URLs that gets generated with every build that gets deployed to these platforms. And we can do the beta testing very quickly. You don't have to do a final rollout. And regarding the scalability, since these platforms are designed to scale automatically, we don't have to worry about maintaining our own infrastructure. Now, I want to give you an example of headless architecture. This is one of the stores that I built when I joined Crystallize, and it uses the same mantra. So I have a shop, and that sells digital posters. Let's look at the demo of this shop, and we'll see how we are using headless architecture even in the context of an e-commerce shop. Although I would again say it's not limited to e-commerce shop, we can follow the same for any website, for any app, but I used it in the context of an e-commerce shop. So this is the home page, and I have a shop that has multiple digital posters under several categories. There are some inspirational ones. I can go to shop now and explore trending designs. I have an about page. There is also search capability where you can search for any of the keywords, and it's going to give you the search results. If I go to shop, and thanks to my mom who sketched this, I will add it to the cart, go to the checkout. I'll fill up some form, and Stripe is being used to collect the payment details. And here's the download file. It's not the production ready code, but good enough. Finally, I also want the users to receive an email when the purchase is already done. So this is the order summary after the purchase has been received in the email. So how did I use headless architecture in this? Let's look at that. So this was the front end using Next.js. And this deployment happened on Vercel. There was a service API. And I had a couple of headless services that I was using. Stripe was used to collect the payment. So one API is Stripe. SendGrid for email integration, the email that you just saw. And I was using Crystallize headless e-commerce PIM product, which provides fast GraphQL APIs to query the catalog, provide search capabilities, and has the capability to provide rich shapes for the product. I have used Crystallize, but if you are designing an application, you could end up using any other service. You could also use, as for your content and for your data, you could end up using Google Sheets, you could use Airtable, you could use any other service. But the idea was to have this headless services separated out and decoupled from the front end. And these are the three layers I used. Now, let's say tomorrow I don't want to use Next.js for my site, for my poster site. I can pretty much rewrite the front end in Gatsby and still host it on Vercel. My service API contract remains the same. It's going to give me back the same details. And SendGrid integration, Stripe integration, I can also add other integrations such as Slack. When the purchase happens, drop me a message on Slack. I can do that. And that all is going to be part of the headless services. And that becomes the easy thing to do if we are following the mantra of headless architecture. We are keeping everything separate, easy to release, and easy to maintain in a developer-friendly manner. Now, if I also decide to roll out, say, a React Native app for the digital posters, I can pretty much reuse the same business logic, the data, and the functionality from the backend services using the same middleware layer. Okay. And again, it is for any website or app, not just for an e-commerce shop. I demonstrated this headless architecture in the form of a poster shop. But you could also think about it if you want to build a CLI tool that could possibly consume the data from your Crystallize, from say Crystallize backend, or it could be a user authentication code, piece of code that you have implemented using, say, services like Auth0, and you want to use those in your CLI tool. Even then, it works the same because your service API layer is responsible for bringing you the response from those headless services. May it be Crystallize, may it be Google Sheets, it could be Stripe, it could be SendGrid, it could be anything for that matter, or an analytics product. But the goal is that you would not have to ship everything together. You can build that CLI tool and you can have your service API being called by that CLI tool, or say in-store software, which is different from the web application, which is different from the mobile app, and is different from the kiosk software. It is an in-person store software that can also talk to the service API layer without having to rupture the experience of shipping the code. Now, I have used these three services. You could use any of these. And that's it. That was the talk all about.
Thank you very much, Deeksha. We do have a question regarding the difference between headless and essentially going in a microservice architecture.
So in a headless architecture, the main concept is we are keeping the backend or any other services that we use in order to provide a feature or functionality different from the front end. We are keeping, you have different channels, as I spoke. We have different channels that can serve as your front end, and that can fit on top of the middleware layer and on top of the services, because the communication happens through that middleware layer. So essentially, you are creating APIs, a number of APIs in the service API or the middleware layer, and they are interacting with the front end. So keeping heads different from the services APIs is the concept of headless architecture, which also essentially uses different microservices. So it's not completely different. The advantage of a headless architecture is you can rip apart one head and replace it with the other one, if that makes sense. Because you can write microservices in, like, without the front end. You can have a layer of a service API which has multiple microservices that serves different purposes and can be called. But in a headless architecture, the focus we are keeping our, and especially in the front end, from the front end standpoint, our focus is to keep different front ends accessing the same API layer, the same services that are on the service API layer.
Awesome. Thank you very much for sharing. So guys, if you have like any questions regarding the talk or the topic that you want to ask Deeksha directly, you can reach out to her via either YouTube or any other social platform, or even the Crystallized community channel, if you want to. Her and all the other developers of the team are more than happy to help you with any questions regarding, headless architectures and things like that we usually talk about. Deeksha, I want to say thanks for the awesome topic, awesome talk, and for the rest of you guys that are looking to go for the last talk of the day with Sean, it is actually in about 20 minutes. I want to say once more, thanks, Deeksha, for the presentation, and thank you all for joining. And I guess we'll see each other in about 20 minutes.
All right.
All right. Thanks, Deeksha. We'll see you soon. Yeah, have a great afternoon.
Yep. Thank you.